Here we have the pH simulation. So here's the beginning. And number one, pH measures what? It measures the acidic or basic nature of a solution. What's neutral pH? Well, right in the middle is neither acidic nor basic. So that's pH 7. What's the basic range of pH? Basic is 7 to 14. I know that makes it look like it's 14. The kid told me 15. I just realized that this scale is misleading. Sorry. It goes to basically to 14, not 15. I don't know why that's there. And this looks like it goes to -1, which is wrong. So acidic goes from 0 to 7. So for everybody who is misled, sorry, I didn't do it. That is dumb on their part. So then it says test the 11 different substances and water. So what's water's natural pH? 7. Then we could put drain cleaner, and its natural pH is 13. And then you can go through and try all the others. Putting in more water does what to the pH? So let's put in water and let's see what happens. So pH is going down, 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 down. Okay. Let's try something else. The pH went below 7. Okay. Let's put in water. pH went up. All right. Let's try something else. Soda pop. Let's put in water and the pH went up. And let's try soap. Put in water and the pH went down. So if it's above 7, it went down. And if it was below 7, it went up. So 19 putting in more water does what to the pH? It makes the pH go toward 7 is really what it does. What do we call putting more water into a solution? That's dilution or diluting. So let's drain out some of the solution. This is 21. What happens to the pH? Nothing. And the reason is that if we pretend for a moment this is orange juice and you pour out orange juice, does the remaining orange juice get less orangey or more orangey? No. So the concentration, the characteristic of the solution doesn't change because you poured some of it out. So on 21, nothing happens. Adding some more of the same substance does what to the pH? So if we add more, it went away from 7 in this case, away from the middle. And if I put in this one and I diluted it, right? We said, and then I put in more, more acid, it goes back down. So in both cases, it pushed it away from 7 for 22. Put only water in the beaker. All right. Let's change 23 to putting an acidic substance in water and the substance makes the pH do what? This is acidic, so it makes the pH go down. The pH is going down as I add more acidic thing. So let's change to water, put in something basic. Then if I add more of that, the pH goes up. That's for 24. Go to the micro version, it says, turn on this. Put in half a liter of drain cleaner. Drain some out. What happens to the H3O plus and OH minus concentrations, blue and pink tabs? So if we drain some out, nothing happens because again, when you drain something out, the concentration stays the same. It's still got the same characteristic. So what happens to the pH? Nothing. Nothing and nothing for 25. 26, put in water. What happens to the molarity of the H3O plus? It's going up. On the left, look on the left, it's going up. Okay, I'm gonna put in water. This is 26, I'm gonna put in water. Look at the left. The H3O plus concentration is going up. What happens to the molarity of the OH minus? It's going down. What happens to the pH? Let's try that again. The pH is falling. Look up top, up top. It's going down. 27, put in more drain cleaner. What happens to the concentrations? Here, let's do some of this. Put in more drain cleaner. What happens to the concentrations? Look to the left. The OH minus is going up. The H3O plus is going down. What happens to the pH? Up top, it's going up. Watch, the pH is going to go down, top, and the H3O plus on the left is going to go up, and the OH minus is going to go down. And that was for 28. Put in the half liter of battery acid. Use the dropper to put in more. What happens to the molarities? Nothing. If you add more of the same thing, the concentration doesn't change. What happens to the pH? Nothing, because the concentrations aren't changing. If the molarities don't change, the pH, fill in the blank, doesn't change. Does draining out solution change the molarities? No, it doesn't. It's still the same stuff, even when you drain some out. On 31, drain the solution as far as possible and just add water. Just add water. This is kind of a repeat. If you go and do that, what's the pH? 7. If it's just water, you get 7 as the pH. Then something way back toward the beginning of school, scientific notation practice. We want the decimal to sit after the first number that's not 0. So I don't want the decimal here. I want it here. This number is getting smaller if I push the decimal there. So I have to make this bigger. So E, by the way, means times 10. So in other words, 3E2 is 3 times 10 to the 2, which is also 300, because that's 100, right? And 3 times 100 is 300. So these are all exactly the same thing. So when I say E4, I mean times 10 to the 4. So if I say E5, I mean times 10 to the 5. So this part here is 10 times bigger than that part right there. If I push this decimal here and made that number smaller, I'm going to have to make the other part bigger. This got smaller by a factor of 10. This must get bigger by a factor of 10, because I'm not trying to change what the number means. I'm trying to keep the same value. If you had a check paying you this or that, it would be literally the same thing. Exactly the same thing. So if you don't quite follow what I mean by the factor of 10 part, then just memorize this part. If this gets smaller, this part must get bigger, and the other way around. So I get 2.4 E5. This part got bigger, that part got smaller. Here we go. I want the decimal after the first number. It's not a 0, so I want 2.4. This got smaller. This part must get bigger, and the tricky bit here that really still stumps me once in a while, and I have to really think about is, and I would write this down, bigger is less negative. Bigger is less negative. Bigger is less negative. So if this number is getting smaller, this part must get bigger, but bigger is less negative. I want the decimal to go one spot left because I need it after the first number that is not a 0. This just got smaller, so that must get bigger. This got smaller by 1 decimal. This must get bigger by 1 decimal, which is the same thing as moving the exponent 1 bigger. This is 10 to the 3. This is now 10 to the 4. I need the decimal to be after the first number that's not a 0. This just got smaller. This must get bigger, and bigger is less negative. When we multiply scientific notation, we can just multiply the regular number looking parts, the 2 times the 4, and we get 8. And then we add the exponent. So we get minus 4 plus a minus 10, and we get times 10 to the minus 14, because minus 4 adds the minus 10, and we get times 10 to the minus 14. Then we can multiply 6 times 4 and get 24, and then add the exponents here. So that's times 10 to the 14, minus 14 again. However, I need the decimal to sit after the first number that's not a zero. I sometimes call it digit dot. I stole that from somebody somewhere anyway. Digit dot. So the decimal's got to go from here to there. That got smaller. This part must get bigger, and bigger is less negative. 2 times 3 is 6. Minus 3 plus minus 5 is minus 8. 8 times 6 is 48. Minus 3 plus minus 5 is minus 8. But I need the decimal to go here. So it's 4.8. This got smaller. This must get bigger, but bigger is less negative. On 35, take the answers you got, and you'll find that they're pretty close to 1 times 10 to the negative 14. And I just kind of made this up, but I'll show you how this works in case you got lost up there. I'll show you. Pretend my tab was here. The tab was here. 2 times 5 is 10, and minus 7 plus minus 8 is minus 15. But I need the decimal to be here, so that's 1.0, and this got smaller. This must get bigger, and bigger is less negative. And so I end up with what I said, that your molarities of H3O plus and OH minus will multiply out to give you that. So then you can drag the tabs around. If you make more H3O plus, the molarity goes up, what happens to the pH? And this is opposite what a lot of people think, but it goes down. If it goes down, then the pH goes up. On the other hand, if the OH minus molarity goes up, the pH goes up. Go ahead and try it. Go ahead and see. And if the OH minus molarity goes down, the pH goes down. So, conclusions. pH is a measure of, well, you might say acidity or basicity. I don't know if that's a word, but we'll pretend it is, huh? Acids ranges from pH 0 to 7. Base goes from pH 7 to 14. And the molarities of the two are inversely proportional to each other. If one goes up, the other must go down. If one goes down halfway, the other one goes halfway up the scale. Diluting a solution makes a solution less acidic or basic, and it shifts towards 7. Remember when we added in the water? It always shifted back toward pH of 7. Pure water has a pH of 7, and any solution with this pH is called neutral.